Welcome back to chapter 10 here. We're going to continue working with radicals, simplifying. We're going to build upon that in these next two lessons. So this is another lesson where I basically split it up into two separate videos, and that's all you're going to have this week because you'll have two classwork assignments and two homework assignments for this lesson. So here's your bell ringer. Give it a try. All right, hopefully you remember this from last week. There are a couple different ways to do it, but I think the best way to do it that I showed in the video is sort of do a factor tree on each of these first. So 6 is just 3 and 2. 24 can be 8 times 3. 8 is 4 times 2, and 2 times 2. So we have a pair of 2's there, a pair of 3's there, and then we have another pair of 2's there. So we have 2 times 2 times 3. 2 times 2 is 4, times 3 is 12, right? So all that gives us 12, and it's out of the radical because everything got paired up. And then if we go back and look at the original problem, we had a 3 on the outside and a 4 on the outside. Those need to be multiplied as well. So 3 times 4 is 12. So it's really 12 times 12, or 144, as your final answer to this. All right. Oops. Okay. So this starts out pretty easily. Basically, your problems are going to look something like this. And it's very similar to the idea of like combining like terms, for example. So I'm just going to show you this quick so that you can see how it's related. If this said actually 6x plus 2x minus 5x, so in place of these square root of 5s, I'm just putting an x instead. You would just add like terms. You would say 8 and 2 is, or 6 and 2 is 8x minus 5x, so you'd say that's 3x, right, as your final answer in that case. This is very similar. If we have a square root of 5 with two separate terms, we have 6 root 5 plus 2 root 5, that is 8 root 5. And then we still have the minus 5 root 5. 8 root 5 minus 5 root 5 is 3 root 5. So the answer before, when I had the x's, was 3x. Now it's 3 root 5. So all we're doing is combining those. They're basically like terms, right? If we could have simplified this square root of 5, we should have tried to do that, okay? But it should be pretty obvious. If I take square root of 5 and try to do a factor tree on it, it's prime. All I can come up with is 5 and 1. So that's not going to get me anywhere. So 3 root 5. All right, so how about this one? It's a little different. We have 4 different terms, and we have a couple different square roots going on. But again, it's very similar to combining your like terms. Whoops. Hold on. Okay. So I could take the 7 root 2 and the 6 root 2, and careful, watch that minus that's with it. So it's 7 root 2 minus 6 root 2. That's 1 root 2. So I can write 1 root 2, or I can just write square root of 2. Same thing. I like to actually just write the square root of 2. And then for my other ones, it's a positive 8 root 11. Let me do this. Positive 8 root 11 and negative 4 root 11. So 8 root 11 minus 4 root 11 is 4 root 11, positive 4. So we're going to have plus. 8 minus 4 is positive 4. And again, I can't do a factor tree on 2. I can't do a factor tree on 11 because those wouldn't go anywhere. So that tells me that that right there has to be my final answer. All right. So how about this one? So none of those match, right? 27, 12, and 75. None of the radicals are the same. However, all of them can be simplified. So that's the first thing I want to do, because they might actually be the same once I simplify them. So I'm going to need some space here. You might do this on like maybe a separate part of your page, but I'll just obviously show it here. So if I take square root of 27, I'm going to say that's 9 times 3, and then 9 is 3 times 3, so that's 3, and then we have 1 left over. So we have a 3 coming out because of that pair, and we have a 3 staying in, okay? And then I already have a 6 on the outside. So if I'm bringing this 3 out, and I have a 6 on the outside already, I have to multiply those. 6 times 3 gives me 18, and then because of this left alone 3, we're going to have to keep that in the radical. So that became 18 root 3. So we went from 6 root 27 to 18 root 3. Those look very different, but if you would pick up your calculator right now and type those in, 6 square root 27 and 18 square root 3, you would get the same answer. You'd get the same decimal, because those are really equal to one another, even though they don't look the same at all. Okay, so I'm just going to kind of do a little divider here for now. Let's do the next one. Let's simplify square root of 12. 12 is 4 times 3. 4 is 2 times 2. So we have a pair of 2's and a 3 by itself. So the 2's coming out, there's already an 8 on the outside. So I have to multiply 8 times 2. That gives me 16 on the outside. And then the 3 stays in. And then the last one over here, square root of 75. That's 25 times 3, and 25 is 5 times 5. So a pair of 5's and a 3 by itself. So a 5 is coming out. There's already, I'm going to circle it up there, there's already a 2 on the outside. 2 times 5 gives us 10 on the outside now, and then the 3 on the inside. So now, if we look at what we have down there, our simplified terms, they actually do all match, or they actually are all like terms, because now they all have that square root of 3 with them, even though it didn't look like they were alike in the beginning. So now we can combine them. And what we're going to want to do there is, I'll erase everything up here so we can use this space up here. We want to look back to make sure we get the signs right that are between the terms, or the operations, you could say. So let me bring these back up here and put the signs back in between them. So it's 18 root 3 plus, because of that plus, 16 root 3 plus, because of that plus, 10 root 3. So we're just adding everything. So all I need to do is take 18 plus 16 plus 10, and then I'll put a root 3 on it. So 18 plus 16 is 34, plus 10 is 44. So it should be 44 root 3 as my final answer. And again, I could type into a calculator right now 44 square root 3, and it's going to give me some ridiculous decimal. And if you would also then type in this original problem to your calculator, you should, if our answer is correct, we should get the same crazy decimal on the calculator. So that's always a good way to check these. Matter of fact, even when I'm just going through doing my answer key, I still do that to check, just to make sure I didn't make any mistakes. The only other way that your answer could be wrong, even if it matches on the calculator, is if your final answer could be simplified. So say, for example, if instead of 44 root 3, we had 44 root 9, this 9 could have been factored down to 3 and 3, and then we could have brought a 3 out, and then we should have a more simplified answer. Otherwise, because that obviously did not happen here, otherwise, if you do the calculator test and it works, then you know you did it correctly. So 44 root 3, 44 root 3. Cool. I think we have one more today. Yep. Oops. Okay. So same thing. I look at those. Those don't match right now. They're also all very large numbers, but we're going to go about it the same way. So it looks like I could probably break all these down. So let's start with 245, the biggest one. And this is always a situation, I think I mentioned this in last week's videos, but I honestly, at least off the top of my head, don't really know which numbers go into 245. But there's one number that definitely goes into 245. Well, one number that's not 1 or 245, because that wouldn't be very interesting, right? And you should think to yourself, 5 should definitely go into 245, because it ends in a 5. So 5 times something is going to give us 245. Here's where you just pick up your calculator. You take 245 divided by 5 and figure out what you should get there. Okay, you should get 49. 5 can't go any further, but 49 is 7 times 7. So there's a pair of 7s and a 5 left alone. And then we had that 6 on the outside to begin with. So the 7s are coming out, or 1 7's coming out. And there's already a 6 out there. So 6 times 7 is 42. And then we're going to have a square root of 5 because of the 5 by itself. Next up, we have 125. Same thing, okay? Let's just say I know that 5 goes into that number. And if I would take 25 or 125 divided by 5, I would get 25. And then I can say 25 is 5 times 5. So 5, pair of 5s and a 5 by itself. So 5 coming out because of that, and a 3 already out there. 3 times 5 is now 15 on the outside. And then that 5 is going to stay under the radical. And then we have square root of 80. Okay, so for this one, you might have other numbers in mind. Let's say 20 times 4. That's one way to get 80. And 20 is 10 times 2. And 4 is 2 times 2. So there's already a pair. I could even circle that now. And then 10 is 5 times 2. So there's another pair of 2's, and then we have a 5 by itself. So this 2 is coming out, so that's a 2. That's another 2. So I'm going to multiply those right now. 2 times 2. That gives me 4. 4 total coming out. And then if I look back up here, there was nothing, there wasn't a number outside of that square root already. So we're bringing a 4 out. That's the only number that we're bringing out. That's the only number that's going to be there. And then the 5 is out there because of that 5 that's still in our box. Okay, so same thing. Give me a sec to erase. Okay, might as well get rid of that one. Yeah, let's just bring the signs down. Actually, it's plus and plus again. So plus, plus. And they're all root 5, so there you go. They all matched again. That won't always happen. Okay, sometimes 2 will match and 1 will be different. Or sometimes you'll have 4 to begin with and 2 will match and the other 2 will match. You know, it's always going to be something different. So 42 and 15 gives me 57. Plus 4 is 61. So 61 root 5. Again, I could check that on a calculator. But there it is. All right. That's it for today. It's all about those factor trees, really. Okay? Just take it slowly. Check on a calculator. That's your best bet. If you really, this is a situation where you shouldn't turn in work that is obviously wrong as soon as I would check it with a calculator, because that just shows that, you know, either you're lazy or you rushed and you didn't take the time and effort to check your answers. So should be doing that. There's your homework assignment. For the huddle, you're going to do the first 6. 1, 2, 3, 4, 5, 6 today. So pause the video, give those a try. All right, and the answers are number 1, 5 root 7. Number 2, 10 root 13. Number 3, 12 root 5. Number 4, negative 3 root 15. Number 5, 8 root 2 plus 4 root 5. And number 6, negative 3 root 13 plus 5 root 2. Or if you want, you could put those in the other order. You could say 5 root 2 minus 3 root 13. Either way. All right. If that was good for you, then you are going to do numbers. I just want you to do numbers 1 and 2 today. Okay, even though you could technically do 3, I'm going to save that for tomorrow's mastery. Otherwise, tomorrow's mastery would only be 1 question. So I don't really want to do that. I'd rather do 2 and 2. So just numbers 1 and 2 on the mastery today. And then there's your homework assignment again. And you can see tomorrow's, or I shouldn't say tomorrow, but the next video is going to be super short. Because if you look over here on the left, there's only a few problems. 2 problems actually is all I'm doing tomorrow, or in the next video. So see you then.